Okay, today we're going to review our properties of tangents and work some associated problems with those. Remember, tangents are line segments or rays that intersect a circle at only one point. If you draw a radius from the center of the circle to the tangent, it should always, the point of tangency, it should always create a right angle. Alright, our first property of tangents was that in a plane, if a line is tangent to a circle, then it is perpendicular to the radius and drawn to the point of tangency. The second property is the converse. If in a plane, if a line is perpendicular to a radius of a circle and its endpoint on the circle, then the line is tangent to the circle. Our third property of tangents was if two segments from the same exterior point are tangent to the circle, then they are congruent. Excuse me. Here, the exterior point would be M. L and G would be the points of tangency. So ML, segment ML, would be congruent to segment NG. Let's work some problems involved with this. First, assume that this was a right triangle, that this is a point of tangency here. Let's solve for x. Well, this problem harkens back to our glorious days with the Pythagorean theorem. And we know that in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. The legs here would be x and 53. X and 53 are the legs. So we square those and add them together, and that should equal the square of the hypotenuse. Well, what's the hypotenuse? The hypotenuse has two parts to it, x and 17. So the hypotenuse, the length of the hypotenuse would be x plus 17, and we have to square that. Now let's solve for x. X squared stays x. 53 squared would be 2,809 equals x plus 17 times x plus 17. X squared plus 2,809 equals, here we have to double distribute. X times x is x squared plus 17x plus 17x plus 17 times 17 would be 289. Combine like terms, x squared plus 2,809 equals x squared plus 34x plus 289. Right. Move terms to the same side. If you notice, we have x squared and x squared. So if we subtract x squared from both sides, it'll cancel itself out. That leaves us with 2,809 equals 34x plus 289. This should be a pretty simple problem from Algebra 1 now. Let's isolate x. First, we subtract 289 from both sides of the problem. Using the subtraction property of equality. 2,809 minus 289 is 2,520 equals 34x. Multiply both sides by the reciprocal, 134 1 over 34. So x would equal 2,520 over 34. Reduce, what number goes into both of these? Well, at least we know that 2 goes into both. So 2520 divided by 2 would equal 1260 over 17. And since 17 is a prime number and it doesn't go into 1260, that would be our answer. The next type of problem we'll see is this one. Let's find all the missing segments. Let's find the measure of AE, HD, GC, BF, and FC. To solve this, we use the property that from an external point, tangents to the segments tangent to the circle are congruent. First, let's look at BE. Well, if BE is 7, and we can assume all these points are tangents. If BE is equal to 7, then BF would also have to be equal to 7. So BF is equal to 7. Well, knowing that BC is 16 and BF is 7, FC must be 9. Now knowing that C is an external point and two segments from C are tangent to the circle, they must be congruent. FC must be the same as CG, must be congruent to CG. So CG must equal 9 also. Now let's look at DG. DG is 3. So using the property that segments from a common exterior point that are tangent to the circle are congruent, HD must equal 3. And finally, since AH is 5, AE must be 5. All right, let's solve for x here. Let's solve for x. X should be in degrees in this problem, and this is 43 degrees is this angle here. How many degrees is x? To solve this problem, first you must know that this is a point of tangency. Knowing that that's a tangent, and this is the center of the circle, this will create a right angle. That's our first property. A right angle is 90 degrees. So now we know there's two ways we can solve this problem. First, x is an exterior angle, so it must be congruent to the two remote interior angles. So x should equal 43 plus 90. So x will equal 133 degrees. The other way you could solve this is knowing that the sum of the angles of a triangle is 180. If this is 90 and this is 43, then this must be 47. A straight line is 180 degrees, so if this is 47, x must be supplementary to that. So x plus 47 equals 180. Subtract 47, subtract 47, x is equal to 133 degrees. All right, W and S are points of tangency, so we mark that with a little point to show that it's tangent. Let's solve for x. Excuse me. To solve this problem, we use the property that H is an exterior point and segments tangent to a circle from the same exterior point are congruent. So WH must equal SH. Substitute in 3x minus 5 equals 7x minus 25. Solve for x. Variables are on both sides of the equation. Move them to one side. Negative 5 equals 4x minus 25. Isolate x. Add 25 to both sides of the equation. 20 equals 4x. Divide by 4, divide by 4, x equals 5. Check your answer. Substitute 5 back in. 3 times 5 minus 5 is 15 minus 5. So WH must equal 10. 7 times 5 minus 25 would be 35 minus 25, which is also 10. So SH equals 10. They're both congruent, so I know I got the problem right. Always check your work when possible. All right, you're going to be given an assignment with some problems similar to these. Good luck with those. If you have any questions, don't be afraid to ask.